The next topic we're going to look at is vectors. So our first question is, what is a vector? A vector has magnitude and direction. So if you just draw an arrow, that can have magnitude and direction, something that looks like this. And you can call your vector v, and you put this little hat on it here, this little arrow, to indicate it's a vector as opposed to a scalar. The magnitude of the vector is equal to the length of the arrow. So the longer this thing is, the more magnitude it has. And the direction is often given as an angle, and the angle is often in standard position. So the rotation this way would be that, and the magnitude would be the length. Vectors are different from scalar quantities because scalars, or scalar quantities, are just numbers. Things like 3, pi, 6i, negative 22 over 7, etc. Those are all scalar quantities. You could think about these as having a magnitude, but they don't have a direction. So vectors we indicate with the arrow over them. So if you see something like this, just an x by itself, you know that is a scalar quantity. Whereas if you see it with the arrow over it, you know it's a vector. So the notation is pretty important when we start getting into operations like multiplying. The negative of a vector has the same magnitude and the opposite direction. So if I take this vector v up here, which goes over 1, 2, 3, 4, 5, 6 boxes to the right and 2 up, the opposite of that would be 6 to the left and 2 down. So if I draw v here again, then negative v would be just the opposite direction. And the interesting thing about vectors is it doesn't really matter where you place these. If two vectors have the same magnitude and direction, then you can start them wherever you want. So this is v here. But also, if I just drew this anywhere else, this would also be v. And that's important later because we're going to pick up vectors and move them around and just draw them wherever we want. But it won't make them actually different vectors. That's something that is allowed. There are a couple ways to add vectors, and one of the easiest is graphically. So if I draw vector v again, I start it here, and then I also draw a vector w, and perhaps I would like to add these two vectors. So I want to define vector y1 is going to be v plus w, like so. So the way to do these is I add vectors by lining them up head to tail. So what that means is I take vector v, and then at the tail of vector v, at the end of it, wait, that doesn't make sense. Is that the head and that's the tail? Whatever, start to finish, you just go from here to here, and then when you get here, you do vector w, which is 1, 2, 3, 1, 2, 3. You get vector w, which looks like this, and then your result, the initial starting place to your final ending place. So this here, your result is vector y1 is this purple line I'm drawing in right there. Vector addition is commutative or commutative. I actually can't remember how to pronounce that right now. But what that means is v plus w equals w plus v. So if we start off and we did this w first, so we start here, we go down 3, right 3, and we do w first, we get here, and then we do v after that. Our resulting vector is the same thing you can see here. This vector y1 that I've drawn from the initial start of w to the end of v is the same as y1 here. It goes over or down and right the same number of units. So it is the same vector. To subtract vectors, we're going to add the negative, just like you might have learned subtraction way back in the day. What that means is if you want to compute y2 equals v minus w, well, what you're going to do is you're going to do v plus negative w. So we just add these two together. So start at v, and you have to plan ahead a little bit here, because if w goes down like this, negative w would go up like this. So if I start v up here, I'm going to do v and then negative w, and I'm going to go through all my text here. So I'll start somewhere down here, and I'll do v, and w goes down this way, so negative w would go up and left instead of down and right. And the result is your original start to your final ending place. This is y2, is this vector here. And that's all about some basics of vectors.